Welcome to the Calculus B section. In this section we'll be discussing trigonometric substitutions. So here we have an equation, and we're actually going to change this to a cube. Here we have an equation, the integral of x cubed over the square root of 16 minus x squared dx. So usually in order to make a situation less convoluted when dealing with integrals, we use u substitution. So we can say that u is equal to x cubed and du is equal to 3x squared. However, the situation arises that this x squared is under a square root. Therefore, we couldn't really substitute in this du because it is 1 over the square root of x squared, which is technically equal to 1 over x, and we wouldn't be able to substitute our dx, and this situation would become more convoluted. So what we do here is we use trigonometric substitution in order to make our situation less convoluted. So what we're going to do is we're going to say that the integral of x cubed over the square root of 4 squared minus x squared dx. And now we're going to establish that x is equal to 4 sine theta, and that means that our dx is going to equal 4 cosine theta d theta. So now that we have that out of the way, we're going to replace our x's and we're going to substitute dx for d theta. So now the integral is as follows: 4 sine theta cubed, and we're going to obviously multiply by 4 cosine theta in order to remove the dx and put a d theta, and this is over the square root of 16 minus 4 sine theta squared. Okay, so that's our new equation, and we want to integrate this integral. So we're going to simplify this out a little bit. We're going to say that we have 4 sine cubed theta times 4 cosine theta over the square root of 16 minus 16 sine squared theta. Okay, so now what we want to do is we want to factor that 16 out of that denominator because we can see 16 and 16. Additionally, we can also multiply these 4's together if we wanted to. It's not 100% necessary, but we could. So what we're going to do is we're going to say that this denominator is actually going to be equal to 16 1 minus sine squared theta. Now that looks very similar to something that we know. We know that cosine squared theta plus sine squared theta is equal to 1. And if we were to subtract our sine squared theta to the other side, well, that just leaves us with cosine squared theta. And that's pretty convenient because we have a cosine theta on the top, and if we were to just take the square root of this, we would get 4 cosine theta on the denominator. So what we want to do here is we're going to say that the new integral is equal to 4 sine cubed theta. Oh, my apologies. I cannot believe I did that. This is 4 cubed, 4 cubed. So on the top, we're going to say 4 to the 4th sine cubed theta, my apologies, times cosine theta over the square root of 16 cosine squared theta. And we know that because we have this, we can actually say this is equal to 4 cosine theta, which means that from our numerator, we can take off 4, we can say it's 4 cubed, and we can take off our cosine theta because this is equal to 4 cosine theta. So our new integral reads 4 cubed sine cubed theta, and over, we'll show the cross out just for clarity. 4 cosine theta, this will go back to 4 then. We remove the cosine theta from the problem, and we remove this, and it's 3. Now it's the integral of 4 cubed sine cubed theta, d theta. Okay. Now we have a seemingly easier integral. So what we want to do here is we want to remove the 4 cubed from the integrand. We're going to say that The 4 cubed is going to be exterior because it is a constant, so we're going to say 4 cubed and then sine cubed theta d theta. Now we've definitely dealt with something like this before. What we want to do is we want to use another trigonometric substitution and say that the integral of sine cubed theta is also equal to sine theta times 1 minus cosine squared theta. Okay. And that is equal to d theta, with respect to theta. So now we're going to use our u substitution because there is a clear consistency here. So we can say u is equal to cosine theta, and du is equal to negative sine theta d theta, which means that our integral is as follows. It is going to be 4 cubed with respect to negative 4 cubed, 1 minus u squared. And that's going to be du. So now what happens is we are going to get the following. It's going to equal negative 4 cubed, and that's going to be u minus u cubed over 3. And we are going to say plus c because it's not over a general region. And now what we're going to say is we're going to plug back our original values of u into the equation. So it's going to be negative 4 cubed times cosine theta minus cosine cubed theta over 3 plus c, which means that our equation is actually going to be negative 4 cubed cosine theta plus 4 cubed cosine cubed theta over 3 plus c. So now to get thetas back to x's, we have to use our original principles of SOHCAHTOA, or sine opposite, hypotenuse cosine, adjacent, hypotenuse, tangent of opposite, hypotenuse, adjacent, my apologies. So now we're going to find the missing side. We're going to deem the unknown value as question mark squared plus x squared equals 4 squared. And now we know that question mark is actually equal to 4 squared minus x squared to the square root. And we know before x is equal to 4 sine theta because that was our original substitution, which means that question mark, or our value cosine theta, is going to equal the square root of 16 minus x squared over 4. And now we can plug this back into our original equation here, which is what the integral we solved for to get our x's back. And we are going to say that negative 4 cubed square root 16 minus x squared over 4 minus 1/3 square root 16 minus x cubed over 4 plus c. And that is how you use trigonometric substitution. Now, I know that was a little bit difficult, but there is a bunch of help on the website, and there's a bunch of practice problems, so I hope that helps further assist you. Thank you.